So what we're doing today, for the rest of the class time, is starting 7.31. 731. 731 is our starting kind of simplifying in operations. So our addition, subtraction, multiplication, division. But we're not going to get to multiplication today. We might end up taking 3 days with this, we'll see. Mainly because normally it takes 2, but we did the PL, progress learning, so that take up some time. That's not bad. Simplifying rational expressions says that we remove anything in common from the top and bottom of the fraction so that the only thing left is either positive 1 or negative 1. So really all this is saying is that it's the equivalent of leaving a fraction as 8/10. We can't say it's just 8/10 because there's a greatest common factor. There's a common factor of 2 on top and bottom. We have to reduce it as far as possible. We have to remove any like terms on top and bottom out as far as possible to where the only thing left is either positive 1 or negative 1. Or we can take a negative out or a positive. There's nothing else we can do to it. So this here, if we have AC over BC, since C is in common on top and bottom, we remove it, telling us that A over B is the simplified version. And we would say that, and they say it up at the top, B is different from 0 and C is different from 0. We cannot have a denominator of 0. We can't divide by 0. That's all that's saying. The second is saying the exact same thing. X plus 3 is in common on top and bottom. So we remove it, giving us this here. Now we do also have something called restrictions. A restriction is any value for x or a variable that would make the denominator be 0. Those are our restrictions. Now we talk about it in terms of equations, rational equations. We call those, extraneous solutions. Extraneous solutions. An extraneous solution is a solution we get from solving that does not work in the original problem, that does not work in the original context. Because when we solve squares or quadratics or Pythagorean theorem, when we try to find the hypotenuse, we get c squared equals this. We take the square root, so c is plus or minus 13. Negative 13 is not a length. We can't have negative length. Negative 13 would be an extraneous solution. It doesn't work. It's an answer that we get from solving that does not work in the original problem. We call those extraneous solutions. Or, especially in expressions, we call them the restrictions, the values that x cannot be. So, we will talk about this here. You'll agree, because I talk about restrictions a lot throughout most of it. And when it comes to the homework assignment, I do not mark off for you not putting them. We're going to put them there so we know what they are, we know how to look at them, we know how to see them, but I'm not necessarily going to make sure you put them every single time. They become very helpful, especially when solving, not so much at this point. So we look at this here, 4 over x times x plus 2. We want to see, is there something in common on top and bottom? Now the default, and it happens time and time again, we say 4 and 2. The 4 on top and the 2 on bottom are in common. We can simplify those out. But unfortunately, x plus 2, they're stuck together. There's no way to break that 4, that 2 out of that with what it is. So there's no way to simplify the 4 on top with this 2 on bottom. There's nothing to simplify. It is simplified. So not every rational expression or every rational equation will simplify. If there's nothing in common on top and bottom, we factor it and it won't go any further we'll just rewrite it back out. The answer for this would be 4 over x times x plus 2. That is simplified. That's as far as it goes. If you do factor it and realize there's nothing in common, leave it factored. There's no reason to multiply the x and x plus 4 back out and say that this is 4 over x squared plus 2x. We're not going to multiply back out. Just leave it in the factored form. So let's look at the second one. We have 2 times x plus 1 over x plus 1 times x plus 3. Do we have something in common on top and bottom? Well, yes, the x plus 1. Now, you can watch this here and see how I do this, because I'm going to do this specifically to show why this works with multiplication, why we can just say the x plus 1 and x plus 1 is gone. And it's dealing with our fractional multiplication. Because when I multiply two fractions together, we multiply the numerator with numerator, the top with top, denominator with denominator, the bottom with the bottom, yes? So on top, after we multiply, we get 2 times x plus 1. Well, I could say this is the same as having 2 on top of one fraction, x plus 1 on top of the other, yes? Because I just broke it back apart. As if we multiplied them back together, we would get back to the top. Yes? The denominator, I'm going to split it up in a specific way. We'll put the x plus 3 over here. X plus 1 over here. Those are the same things, I just have them split. Are you comfortable with how this is split? I split it up for this way and this reason for a specific purpose. Here, we have x plus 1 over x plus 1. Anything divided by itself is 1. So this whole expression is going to reduce to 1, yes? Which tells me I have 2 over x plus 3 times 1, which is just going to be 2 over x plus 3. It simplifies out. They cancel out. They reduce to 1. We're just left with the 2 over x plus 3. We can do this because the top 2 terms and the bottom 2 terms are being multiplied together. We can split them up this way. That's the nice thing with multiplication. I cannot do that with the x plus 3. I can't just write it as 2 over x plus 2 over 3. That is not the same expression. Because for us to add or subtract 2 fractions, the denominators have to be the same. And we can't mess with the denominator like that with addition and subtraction. Multiplication, yeah, we can pull them apart, cancel them out. Now, really, from here on out, we're not going to do this. We're not going to do it this way. I show you this to show you, okay, if it's multiplication, we can put the like terms on top of each other in one fraction. They will reduce to 1, leaving us with the non-like terms. At this point here, we're going to say, these two simplify out, they cancel out, they simplify to 1, leaving me with 2 on top and x plus 3 on bottom. Because from here on out, this is how we're going to simplify. I wanted us to see the other way first to show this is why it works with multiplication. Because we can split them up into those 2 separate fractions with what's in common on top and bottom, simplifying out. Questions on this here? Our restrictions. Now, we talk about restrictions with expressions because in an expression, x in this case can be any real number. We don't look at complex numbers. We look at any real number because it's supposed to be an expression of any value of x. However, the denominator cannot be 0. So any expression, so x plus 3 or x plus 1, that would make the denominator be 0 has to be excluded. It is our restriction. We're removing those there. Now with the x plus 1, to find that value, well, we set it equal to 0 and see what value of x would make it be 0. For this here, we would subtract 1, telling us that if x is -1, it would make this expression be 0, which would turn the whole denominator to 0. It doesn't matter that the numerator is also 0, because 0 divided by 0 does not work any more than 2 divided by 0. So x cannot be -1. We're going to do the exact same thing with x plus 3. These cancel, telling me that if x is -3, we'd have a denominator of 0. So the other value of x that we cannot have is -3. Questions on this here? Most books, most places, not all, but most, would tell you that for this here, the answer is 2 over x plus 3. And if they ask you to state the restriction, they would tell you that x is not equal to -1. They would say that's the only restriction. And the reason they say that is because, well, kind of they're making the assumption that we know that, hey, look, in our answer, the denominator is x plus 3. So we know x cannot be -3 because it is in the bottom of the fraction. It's still stated, it's still there that we could find that. They want x cannot be -1 because the one spot where -1 would be a restriction here has been simplified out of this expression, so it's not listed anymore. So a lot of places, they only want restrictions listed of expressions that have been removed or simplified out. They don't want you, or you not have to, list the ones that are still included. I think that's a little silly, because realistically, the amount of time it took us to find both of them was not a whole lot. So really, x cannot be -1 and x cannot be -3. Just because they didn't list it doesn't mean it's not a restriction. They're just saying x plus 3 is still a part of the problem, so we can still see that it is a restriction. Questions? Now, as I said earlier, for the most part, I'm going to list them here. We'll do them in solving, but I'm mostly doing this so that we know what they are. And if we're asked about them, we know how to find them. So like the ACT tomorrow, where if it asks for you to solve this here, or simplify this here, and it lists the restrictions, we know what they're talking about. If they talk about extraneous solutions, given the following rational equation, what are the extraneous solutions, or what values of x would be an extraneous solution? It's just asking what values of x would make the denominator be 0. Now, this one here is a little different than the one before it, because this is not factored. And as much as we would like to, we cannot cross the x squared and x squared out, because they are not being multiplied, they are being added and subtracted. So they're stuck together. We can't just cross them out. Now, the first thing I would say, especially in simplifying these here, look at the top and bottom, or look at all the spots where we need to factor and figure out which one you can see the factors of first. Because when I look at this here, I see x squared minus 4x minus 12, which is fine, but I notice that the denominator is x squared minus 4. I have two terms being subtracted. And I have an x squared, so there's a good chance it's a difference perfect squares. X squared is a perfect square, it's x and x. 4 is a perfect square, it is 2 and 2. So x squared minus 4 should factor 2. X plus 2 times x minus 2, yes? Now it seems odd why I say focus on that one first. Because why does it make a difference? Because in the end, we need to factor the top and bottom, reduce what's in common, and go from there, yes? Well, by factoring the x squared minus 4 to x plus 2 and x minus 2, if something simplifies, one of the top two factors has to be what? X plus 2 or x minus 2. Because if I don't have x plus 2 or x minus 2 as a factor on top, nothing simplifies because there would be no common expression on top and bottom. Nothing factors out, nothing simplifies out, so it's simplified as is. So it gives me a hint. If something's going to simplify, it has to be one of these two. So let's look at factoring the top. Always look for greatest common factor, especially at this point on in the rest of the semester. Correct me if I'm wrong. I skip over greatest common factor time and time again. And it's not because I don't think it's important, but by this point, x squared minus 4x minus 12, there's no greatest common factor, so I normally just barge through or I just skip over it because there's not one. It is always important to check. Always check for greatest common factor. So, none there. Third term is negative, so the signs are opposite. One's going to be positive, one's going to be negative. Now we need to find the factors of x squared, our first and third terms. Factors of x squared are x and x. That's the only set of factors. Factors of the third term. 1 and 12, 2 and 6, 3 and 4. And if we're looking for the factors of 12, would we look at 1 and 12? No, because if we did 1 and 12 and those are the actual ones, nothing would simplify. I wouldn't have an x plus 2 or an x minus 2. No reason to look at that one. 3x and 4, or 3 and 4, again, we don't have anything in common. But if we did 2 and 6, or 6 and 2, here, I do have an x plus 2 and x plus 2 in common. It would simplify out. Or the other way, we'd have an x minus 2 and x minus 2 in common. Now again, before I would go start crossing things out, I would still check it. X times negative 6 is negative 6x. 2 times x is positive 2x. Negative 6x plus 2x, negative 6 plus 2 gives us negative 4x, telling us that our middle term is correct. So these are the correct factors, which means what? X plus 2 and x plus 2 are now in common on top and bottom. They would both simplify out. And it would reduce to this here. Now again, we can't simplify the 6 and 2 as much as we would like to, because that x minus 6, the x and 6 are stuck together. The x minus 2, the x and 2 are stuck together. If it had been x times 6 or 6x over 2x, yes, we can simplify because they're being multiplied. Multiplication, we can split them apart and simplify down. That addition and subtraction makes things tricky. Because if I wanted to simplify, quote unquote, simplify this further, it would be x over x minus 2 minus 6. We can break the top two up, but the bottoms would still be x minus 2. This is as far as it goes. Questions on this here? Restrictions. We do have two of them, because x minus 2 and x plus 2 both showed up in a place that would cause a division of 0. Now the x minus 2, if we want to see what value of x will make that be 0, well, we solve for x, we add 2 to both sides. And instead of x is 2, we'd have a division of 0, which does not work. So x cannot be negative 2 or positive 2. Do the same thing with x plus 2. As I was just saying, x cannot be negative 2. So the restrictions for this here would be positive 2 and negative 2. Some will just say positive 2. But those two values of x will not work. 6 is fine. Because our x minus 6, it would give us a numerator of 0. but we'd have 0 divided by 4, which is 0. That's fine. Questions on this here? You ready for this one here? Now again, especially on the ACT, if something like this shows up, simplify the following rational expression, I would start with the denominator. X squared minus 9 is a difference of perfect squares. So we would indeed get x plus 3 times x minus 3. Now again, like I said, it's going to happen time and time again, especially since we got out of factoring. There is no greatest common factor between x squared and 9. They are perfect squares, so we get x plus 3 and x minus 3, yes? If something simplifies, and we did have, especially on the ACT, multiple choice answers, yes? What is one expression we have to have on bottom? X plus 3 or x minus 3. One of those two has to show up on bottom. If they don't, and the answer choices doesn't have x plus 3 or x minus 3, one of those two, we know it's wrong. It has to have it. Now the numerator, x squared minus x minus 12. There is no greatest common factor. The third term is negative, so the signs are opposite. So one's going to be positive, one is going to be negative. Factors of x squared are x and x. Now our factors of 12, 1 and 12, 2 and 6, 3 and 4. Well, again, just like the one before, we're not going to look at 1 and 12. Which one are we going to look at? 3 and 4. Where do you want to put the 3? Right here. We can check and make sure. X times negative 4 would be negative 4x. 3 times x would be positive 3x. And negative 4x plus 3x, negative 4 plus 3 would give us negative 1. Telling us these are indeed the correct factors. Now, since we do have x plus 3 in common on top and bottom, they would cancel out. Telling us that we have x minus 4 over x minus 3. Questions on this here? Yes, the parentheses aren't necessary on top and bottom. We could just have x minus 4 over x minus 3. We don't need those there because there's nothing in front of it. There's no sign. There's no number. But I think it is good to keep those in mind and keep the parentheses there as a reminder to us ourselves that that x minus 4, that is one term, they're stuck. We can't just cross the x and x out. I can't just simplify the 4 and 3. Well, they wouldn't simplify anyways. But reminding ourselves that they're stuck together. Now our restrictions for this here, the two places where the denominator can be 0 is our x plus 4, x plus 4, x plus 3, and x minus 3. They're the two places where the denominator could be 0. And with our x minus 3, we'd add 3 to both sides, telling us if x is positive 3, it would make this x minus 3 be 0, because 3 minus 3 is 0, so x cannot be 3. With our x plus 3, we would subtract 3 from both sides, and our 3 minus 3 would be 0. 0 minus 3 is negative 3. So with our x plus 3, we would get a division of 0, so x cannot be negative 3. It's our other restriction. Questions on this here? This is where we're going. Let's see here. We'll do this one here, and then we'll stop after this because we are essentially out of time. If we look at this here, factoring the top and bottom, well, x plus 4 on top, there's no greatest common factor between x and 4. Now, up to this point, I would have started with the x squared minus 16, because that is a difference of perfect squares, yes? But if you notice on top, the degree is 1. And if the degree is 1 of a polynomial expression, the only way we can factor it is with a greatest common factor. And since there's not a greatest common factor between x and 4, it's actually just x plus 4. Now the denominator, as we said, is a difference of perfect squares. We have our plus and minus, x, and 16 would be 4 and 4. Now even though they're not listed, as we talked about this already, really we can think of the numerator, that x plus 4 having parentheses around it, because that x and 4 are stuck together. So what do we have in common on top and bottom? X plus 4 and x plus 4 are in common on top and bottom, yes? Now, the denominator will indeed be x minus 4, because that's the only thing left, yes? What would the numerator be? Because y'all were looking at me because I have a feeling the instinctual answer is 0, but it's not 0. It's 1. Because when anything simplifies out completely, it's going to reduce to 1. Because what we're saying is x plus 4 over x plus 4, when it divides out completely, it reduces to 1. Or if we split it up, we'd say 1 times x plus 4. The 1 is still there. Questions on this here? We'll finish this tomorrow.